Welcome back. In the next part of this lecture, we're going to talk about the inverse trig functions for cosine and tangent. So a lot of what I said before about inverse sine is going to be similar to what I'm going to say about inverse cosine and inverse tangent. Some of the details will change, but the big ideas are going to remain the same. Namely that for finding the inverse trig function for cosine or for tangent, we're going to need to restrict our domain. And in the case of cosine, we're restricting our domain from 0 to pi. And if you're remembering the graph of cosine, that's because between 0 and pi radians, the graph of cosine would be 1 to 1, having its maximum value when x is 0 and its minimum value when x is pi. So we're restricting our domain here from 0 to pi, and the whole idea behind the inverse cosine function is exactly the same as the inverse sine function, switching inputs and outputs. You know that cosine of pi over 4 is root 2 over 2, so that means cos inverse of root 2 over 2 should be pi over 4. Notation is similar. Cosine inverse, you could write it as cosine with a little -1 of x. That's inverse cosine. You could also call it arc cosine, and that also means exactly the same thing. And a lot of the details here are also the same. You know, again, that domains and ranges are switched when we look at our inverse functions. So for cosine, the domain from 0 to pi. So cosine inverse, the range is from 0 to pi. Cosine had a range from -1 to 1. So cosine inverse has a domain from -1 to 1. And the same business of coordinates being switched is true here. For cosine, you have, for example, the point pi -1, and for cosine inverse, you have the point -1 pi. And we're going to find the exact values for our trig function, our inverse trig functions, the same way. Sometimes we'll be able to make reference to the graph of cosine. Sometimes we'll have to use a special triangle. Sometimes we'll need to use our calculator. For cosine inverse of 0, this again is an easy one to do if we know our graph. So if we're thinking about the graph of cosine of x, you know that cosine of pi over 2 is 0. And so that means cosine inverse of 0 should be pi over 2. And similarly, you know that since cosine of pi is equal to -1, then that means cosine inverse of -1 is pi. For the next one, we have cosine inverse of -root 2 over 2. And I know that root 2 over 2 shows up when I'm looking at my special triangle where the angles are 45, 45, and 90. So if I get my special triangle pi over 4, and pi over 2, I know that cosine of pi over 4, that's positive root 2 over 2. I can find that with my special triangle. But I know here I'm looking not for positive root 2 over 2, I'm looking for negative root 2 over 2. And so that means that we're not going to be thinking about an angle that's in quadrant 1. Rather, we're going to be having an angle that's in quadrant 2. Remember that cosine inverse, it's only giving us output between 0 and pi. And between 0 and pi over 2, that's where cosine is positive. Between pi over 2 and pi, that's where cosine is negative. So we're somewhere in quadrant 2. And in fact, we can do better than that. We know that the reference angle has to be pi over 4. So if you're in quadrant 2 and the reference angle is pi over 4, then your angle must be 3 pi over 4. So we know that cosine of 3 pi over 4, that's negative root 2 over 2. So cosine inverse of negative root 2 over 2, that's 3 pi over 4. For the next one, cos inverse of negative 0.2, this is not a number that comes from any of our special triangles. It's not a number that I can easily find from my graph of cosine, so this is where I will need to use my calculator. And if I put in second function cosine for cosine inverse, negative 0.2, making sure your calculator is in radians, you should get about 1.772 as your answer. Again, remember that for these inverse trig functions, the output is an angle, but an angle measured in radians. And so that means if you're using your calculator for inverse trig functions, make sure that it's in radians mode first. The same sort of business that we had before with composition of sine with its inverse, same sort of ideas hold true here. If we have a value of x that's in the domain, then cosine composed with cos inverse, that they'll undo each other, and cosine inverse composed with cosine will undo each other. In the case where you've got a value of x that's not in the domain of cosine inverse, then cosine inverse would be undefined, so cosine composed with cosine inverse would be undefined. And if you had an angle that was outside of quadrant 1 or 2, outside of that restricted domain, then for cosine inverse composed with cosine, just remember that cosine inverse is only going to give you an angle in that quadrant, and it will give you the angle that has the same value for cosine as the angle you started with. So for example, something like this, cosine of cosine inverse of negative 0.87. Again, the domain for cosine inverse, that's from negative 1 to 1, and we are definitely inside that domain. So cosine and cosine inverse will cancel each other out in a sense. You'll have negative 0.87. And same thing for the second one, 3 pi over 4. That's an angle that's in our restricted domain from 0 to pi. So since this is an angle in that domain, then that means that cosine inverse composed with cosine, that they should undo each other, and I should be left just with 3 pi over 4 as my answer. For part C, we're looking at cosine inverse of cosine of 7 pi over 6. And if I did a little quick drawing here of my angle, 7 pi over 6 is in quadrant 3. 7 pi over 6 is in quadrant 3 and also has a reference angle of pi over 6. Now, the one thing that we know is that in quadrant 3, cosine would be negative. And the other quadrant where cosine is negative is quadrant 2. So we know that whatever cosine of 7 pi over 6 is, it's something negative. And we know cosine inverse, it's going to give me an angle that's in quadrant 2 that has the same value as cosine of 7 pi over 6. And so if we're thinking about this, well, if you're in quadrant 2, you would have to have the same reference angle, which is pi over 6. And that would only happen if that angle were 5 pi over 6. So you can confirm that cosine of 7 pi over 6 and cosine of 5 pi over 6, that they're both equal to each other. They're both equal because they're both in quadrants where cosine is negative, and these two both have the same reference angle, so therefore they must be equal to each other. So, since cosine of 7 pi over 6 and cosine of 5 pi over 6 are equal, and 5 pi over 6 is in our restricted domain from 0 to pi, then 5 pi over 6 will be what I get out of my inverse cosine function. So cosine inverse of cos of 7 pi over 6 is 5 pi over 6, and I know that since cosine of 7 pi over 6 is equal to cosine of 5 pi over 6. For the next one, cosine composed with cosine inverse, This one's the fast one to do. This is undefined because 1.57 is not in the domain of cosine inverse. So that means that cosine composed with cosine inverse of 1.57 has to be then undefined. All right, let's do one more here. I'm looking at cosine inverse composed with cosine of 7 pi over 4. And if you were to draw 7 pi over 4, 8 pi over 4 is the same thing as 2 pi, or a full circle. So 7 pi over 4, that's just a little bit less than it. And that puts us in quadrant 4. Quadrant 4 where cosine happens to be positive. Now, again, reminder that cosine inverse is restricted to giving you values in quadrant 1 or quadrant 2. So that means that we're not going to get 7 pi over 4 as our output here. We're going to have to get something in quadrant 1 or quadrant 2. And since we're in a quadrant where cosine is positive, then that means the answer that we're going to get is not in quadrant 2 because that's where cosine happens to be negative. So that means we're going to get an angle that's in quadrant 1, and it has to be an angle that has the same value as cosine of 7 pi over 4. And that would be an angle with the same reference angle as 7 pi over 4. You can confirm that pi over 4 and 7 pi over 4, that those both have the same value because they both have the same reference angle and they're in quadrants where cosine is positive. So since cosine of pi over 4 and 7 pi over 4 are equal to each other, then you know that cosine inverse of cosine of 7 pi over 4 should just be pi over 4. For inverse tangent, much the same sort of an idea here. We're restricting our domain, and it's a similar domain as for sine, except notice that we don't have the endpoints included. For sine, we restricted the domain from negative pi over 2 to pi over 2, including those endpoints. For tangent, we're not including those endpoints, and of course, the obvious answer for why we're not including those endpoints is because we have vertical asymptotes on the tangent function. We have vertical asymptotes at negative pi over 2 and also at pi over 2. So those are not points that are on our graph of tangent of x, which means that those can't be values that are included in our domain. Same sort of thing is true for all of our trig functions and their inverses. Again, they're switching inputs and outputs. So if you know that tangent of pi over 4 is 1, then tangent inverse of 1 is pi over 4. And again, same thing that I'd said about the inverse sine function and inverse cosine function. Inverse tangent, much in the same way, could be written as tan to the power tan with a little minus 1, or it could be written as arctan, the arctangent function. One sort of unusual thing, or I guess unique thing, I guess might be a nicer way to put it, for the tangent function as compared to the sine and cosine ones. For sine and cosine, both of those, when we restricted the domain and had a restricted range, but for tangent, although we've restricted the domain, the range is all real numbers. That's sort of the unusual thing here. That unlike sine and cosine, where there was only a limited range, tangent, its range is all real numbers. And that means that for tangent inverse, the domain would be all real numbers. So unlike sine inverse and cosine inverse, which have restricted domains, tangent does not. Tangent inverse is defined everywhere for all real numbers. Also notice here that for the graph of tangent, you had two vertical asymptotes on that little restricted domain that we were getting close to. and that meant for tangent inverse there were two horizontal asymptotes. Okay, so same thing that we do for all of our trig functions, finding the inverse trig functions either by knowing the graph of tangent or by using special triangles. So if you know the graph of tangent, then the first one is easy enough to answer. Tangent inverse of 0 is 0, and we know that since tangent of 0 is equal to 0. And you know that because on the graph of tangent, it passes through the point 0, 0. Since it passes through the origin, then 0, 0 is the point on the graph, which means that tangent of 0 is 0, which means tangent inverse of 0 is 0. Again, this one you could get from a special triangle or knowing the graph of the tangent function. If you're thinking in terms of your special triangles, you know that for tangent, that you would get values of 1 if you're talking about 45 degrees. That's where tangent is 1. And not a surprise then, at negative 45 degrees, tangent has a value of negative 1. So since tangent of pi over 4 is positive 1, then you know that tangent of negative pi over 4 is negative 1, which means that tangent inverse of negative 1 should be negative pi over 4. And again, this could have come from the graph. Remember that we know that in the graph of tangent, some nice points are 0, 0, pi over 4, 1, and negative pi over 4, negative 1. So if we knew the graph of tangent, then that would be an easy one to do. But if not, we could still think in terms of special triangles. Tangent inverse of negative root 3. This is, again, something where we're going to need to think about special triangles for a moment. And I know that root 3 shows up in my 30, 60, 90 triangle. Pi over 6, pi over 3, and pi over 2. If you're looking at that special triangle and you're looking at tangent of pi over 3, you know that that would be opposite over adjacent. Tangent of pi over 3 would be root 3 over 1. And root 3 over 1, of course, that's the same thing as just root 3. Now, we want where is tangent inverse of negative root 3, or in other words, what's the angle where tangent of that angle gives us negative root 3. And I know what that angle should be. It should be tangent of negative pi over 3. And that's, again, going to tell us that since tangent of negative pi over 3 is negative root 3, then that means tangent inverse of negative root 3 is negative pi over 3. Tangent inverse of 807, that's certainly not something that comes from any of my special triangles. So I will need my calculator, and I find that tangent inverse is approximately 1.56955, so about 1.570 if you're rounding it to 3 decimal places. And of course, that's not an angle, that is radians. Now, as far as our tangent function goes, we have one nice thing here that we didn't have for sine and cosine, and that's tangent composed with tangent inverse is always going to undo each other. And that's because since tangent inverse, it's defined for all real values of x. In other words, every x is in the domain of tangent inverse. So tangent always undoes tangent inverse, which is nice. The reverse, of course, we're going to have two options there. We could be looking at tangent composed with tangent inverse, where the angle is inside our restricted domain, in which case tangent undoes tangent inverse, or sorry, tangent inverse undoes tangent. But you could have the possibility where the angle that we've been given is not in quadrant 1 or 4, so we'll have to do the adjustment to give us an angle that is in that quadrant that does give us the same value for tangent as the angle we were given. So some things like this, tan inverse of negative 123.45, we know that that should just be negative 123.45. Since any value that we have is going to be in the domain of tangent inverse, then tan composed with tan inverse, they'll undo each other, and we'll be left with negative 123.45. If we're thinking about tangent inverse composed with tangent, pi over 10, that is in our restricted domain. Remember that the restricted domain for tangent was from negative pi over 2 to pi over 2. And so that means that we would have tangent inverse would cancel tangent out just nicely, leaving us with pi over 10. Now for these two, we're both going to need to make a couple of adjustments because neither of these angles are in our little restricted domain from negative pi over 2 to pi over 2. If you looked at 3 pi over 4, you'd see that that angle happens to be in quadrant 2 and has a reference angle of pi over 4. Now in that quadrant, you happen to know that tangent is negative. And that means that the angle that we're going to get out of this will be an angle where tangent is negative. And since tangent inverse only gives us outputs in quadrant 1 and 4, and since we know that we're looking for an angle where tangent is negative, then I guess we have to be in quadrant 4. And we have to have the same reference angle as our given angle, which is pi over 4. So that must mean that our angle that we're talking about is negative pi over 4. And so I know that tangent inverse of tan of 3 pi over 4 is negative pi over 4. And I know that since tangent of 3 pi over 4 and tangent of negative pi over 4, that those are both equal to each other. And negative pi over 4 is in our little restricted interval from negative pi over 2 to pi over 2. Same thing with this last problem that I have here. Tangent of 4 pi over 3, if you're looking at that angle, that is in quadrant 3. And has a reference angle of pi over 3. And you know that in this quadrant that tangent is positive. So we must have as our output an angle that's in quadrant 1 or 4, but it has to be in a quadrant where tangent is positive, so I guess we're in quadrant 1. And it has to have the same reference angle as our given angle, which is pi over 3. So our angle must be pi over 3. So tangent inverse of tangent of 4 pi over 3 is pi over 3. And this I know since tangent of 4 pi over 3 is equal to tangent of positive pi over 3.